Today I'll be reading from the PostgreSQL 14 Administration Cookbook by Simon Riggs and Gianni Gioli. This is a cookbook, so it just has, I guess, a bunch of recipes, and that's what the book calls it too, on how to do a whole bunch of stuff with Postgres. And I thought it would be fun to read chapter 11, which is about the backup and recovery of your Postgres server. Now, obviously, this chapter is pretty big, so I'm probably not going to read all of it. I'm also sorry if you can hear noise outside. There's cars and stuff. But I thought it would be fun to do this because I think any database administrator or anybody that works with Postgres will know that backup and recovery is not a very relaxing topic. Unless you do it really well, then I guess it's no big deal. But most people get a heart attack when they have to do a backup or some kind of rollback or anything like that. And so I thought it would be fun to read this. This is also my first ever ASMR video, so I'm not even sure if I'll upload this. But we'll see. Alright, let's start. Backup and recovery. Most people admit that backups are essential, though they also devote a very small amount of time to thinking about the topic. The first recipe in this chapter is about understanding and controlling crash recovery. You need to understand what happens if a database ever crashes so that you can understand whether you need to perform a recovery operation. The next recipe is all about planning. That's really the best place to start before you perform backups. The physical backup mechanisms here were initially written by Simon Riggs, one of the authors of this book, for PostgreSQL 8.0 in 2004, and they have been supported by him ever since, now with increasing help from the community as its popularity grows. Second Quadrant and EDB have also been providing database recovery services since 2004, and regrettably, many people have needed them as a result of missing or damaged backups. It is important to note that in the last few years, the native streaming replication protocol has become more and more relevant in PostgreSQL. It can also be used for backup purposes too, not only to make a base backup with PG base backup, but also to stream WAL files using PG receive WAL. Given that some of the recipes in this chapter will use streaming replication, we will assume that you have a basic familiarity with it and refer to the next chapter for more details. As a final note, all of the examples regarding physical backup and recovery in this chapter are thoroughly explained so that you can understand what is happening behind the scenes. However, unless you have very specific requirements dictating otherwise, we highly recommend that when in production, you use Barman, our open source backup and recovery tool. Well, that's kind of weird to push it like that, but I guess that makes sense. Or a similar product that is specialized in this area. The last two recipes in this chapter will introduce Barman. Oh, they're really shilling their Barman tool. I've never used Barman, mostly because I don't do backups other than PG dump. But I'm also not a DBA, so it's not my specialty here. I'm not in charge of backups, so no shame in that. In this chapter, we will cover the following recipes: understanding and controlling crash recovery, planning your backups, hot logical backup of one database, hot logical backup of all databases, backup of database object definitions, a standalone hot physical backup with Barman, recovery of all databases, recovery to a point in time, recovery of a dropped/damaged table, recovery of a dropped/damaged database, extracting a local backup from a physical one, improving performance of logical backup recovery, improving performance of physical backup recovery, validating backups, understanding and controlling. Okay, this is on a new page. Actually, let me take a drink first, because I'm thirsty. There we go. Okay, so this is on a new page. I think this is the first recipe that we'll read. As I said earlier, I'm not going to gonna do all of these recipes because that would take me by probably an hour. Maybe if you want that, I can probably do that for you, but not now. I'm sorry if that was loud. Crash recovery is the PostgreSQL subsystem that saves us should the server crash or fail as part of a system crash. It's good to understand a little about it and what we can do to control it in our favor. How to do it. If PostgreSQL crashes, there will be a message in the server log with the severity level set to panic. PostgreSQL will immediately restart and attempt to recover using the transaction log or the write-ahead log, wall. The wall consists of a series of files written to the PG_wall subdirectory of the PostgreSQL data directory. Each change made to the database is recorded first in wall. Hence the name write-ahead log, which is a synonym for a transaction log. Note that the former is probably more accurate since in the wall there are also changes not related to transactions. When a transaction commits, the default and safe behavior is to force the wall records to disk. Should PostgreSQL crash, the wall will be replayed, which returns the database to the point of the last committed transaction, ensuring the durability of any database changes. Note, database changes themselves aren't written to disk at transaction commit. On a well-tuned server, those changes are written to disk sometime later by asynchronous processes, such as the background writer or checkpointer. Crash recovery replaces the wall, but from what point does it start to recover? Recovery starts from points in the wall known as checkpoints. The duration of a crash recovery depends on the number of changes in the transaction log since the last checkpoint. A checkpoint is known as a safe starting point for recovery, since it guarantees that all of the previous changes to the database have already been written to disk. A checkpoint can become a performance bottleneck on busy database servers because of the number of writes required. We will look at the number of ways to fine-tune that, but you must also understand the effect that these tuning options may have on crash recovery. A checkpoint can be either immediate or scheduled. Immediate checkpoints are triggered by the action of a super user, such as the checkpoint command, and they are performed at a full speed. So an immediate checkpoint will be completed, or will complete as soon as possible. Scheduled checkpoints are decided automatically by PostgreSQL, and their speed is throttled to spread the load over a longer period of time and reduce the impact on other activities, such as queries or replication. Next page. Two parameters control the occurrence of scheduled checkpoints. The first is checkpoint_timeout, which is the number of seconds until the next checkpoint. While this parameter is time-based, the second parameter, max_wall_size, influences the amount of wall data that will be written before a checkpoint is triggered. The actual limit is computed from that parameter, taking into account the fact that wall files can only be deleted after one checkpoint, 2 in older releases. A checkpoint is called whenever either of these two limits is reached. If checkpoints are too frequent, then the amount of I/O will increase, so it's tempting to banish checkpoints as much as possible by setting the following parameters. And here it's like a code block. And they set the max wall size to 20 gigabytes and the checkpoint timeout to 1 day. Which, and again, I'm not a DBA or anybody who has any business in controlling any of these things, but that seems a little long for me. Well, I guess it doesn't really matter, just your recovery time or the playback time would be a little long. Well, I don't know, it depends on your stuff, right, on your database, so don't mind me, I'm just providing commentary. However, if you do this, you should give some thought to how long crash recovery will take, and whether you want that. See, I was right. You must also consider how many changes will accumulate before the next checkpoint, and more importantly, how much I/O the checkpoint will generate due to those changes. Also, if you are using replication, then you might not care about the recovery time, because if the primary crashes, you can fail over to archiving. See archive underscore command in the hot physical backup and continuous archiving recipes. The wall underscore keep underscore segment settings. You will need at least 16 megabytes times wall underscore keep underscore segments of space. What? 60? Okay, that makes sense. In contrast to max wall size, with min wall size, you can control the minimum allotted to wall storage, meaning that Postgres will recycle existing wall files instead of removing them. I don't know why you would do that. I'm sure there's a very good reason for that. I guess, I'm not going to make a guess because I don't know, but it's probably something to do with like really, really low level file buffers or something, but I could be wrong. Let me know in the comments. Recovery continues until the end of the transaction log. Wall data is being written continually, so there is no defined endpoint. It is literally the last correct record. Each wall record is individually CRC checked so that we know whether a record is complete and valid before trying to process it. Each record contains a pointer to the previous record, so we can tell that the record forms a valid link in the chain of actions recorded in the wall. As a result, recovery always ends with some kind of error in the reading the next wall record. That is normal and means the next record does not exist yet. That's funny. I bet that would freak me out if I was doing like a production database rollback and it says you can't find wall file. That would be stressful, to say the least. Recovery performance can be very fast, though its speed does depend on the actions being recovered. The best way to test recovery performance is to set up a standby replication server, as described in Chapter 12, Replication and Upgrades, which is actually implemented as a variant of crash recovery. There is more. It's possible for a problem to be caused by replaying the transaction log so that a database server will fail to start. That's a problem. Some people's response to this is a utility named PG reset wall, which removes the current transaction log files and tidies up after the operation has taken place. The PG reset wall utility destroys data changes, which means data loss. If you do decide to run that utility, make sure that you take a backup of the PG wall directory first. Our advice is to seek immediate assistance rather than do this. You don't know for certain that doing this will fix a problem, but once you've done it, going back will be hard. I can believe that. When discussing min wall size, we mentioned that wall files are recycled. What this actually means is that older wall files are renamed so that they are ready to be reused as future wall files. This reduces commit latency in case of heavy write workloads because creating a new file is slower than writing into an existing one. See, I'm a genius. That's like basically what I said earlier. I love how up until this point we haven't really even talked about backups and just wall, which I guess I don't think. Well, I guess you could, but I don't think anybody would feel like the wall directory is a backup. I mean, if the Postgres process crashes, obviously it will return, hopefully, right? But when I think of backup, I think of a little more like severe problems. But who knows? Planning your backups. This recipe is all about thinking ahead and planning. If you're reading this recipe before you've decided to take a backup, well done. Well, thank you. The key to understand is that you should plan recovery, not your backup. The type of backup you take influences the type of recovery that is possible, so you must give some thought to what you are trying to achieve beforehand. If you want to plan your recovery, then you need to consider the different types of failure that can occur. What type of recovery do you wish to perform? You need to consider the following main aspects: full or partial database, everything or just object definitions, point-in-time restore performance. I don't know what that last one is. We need to look at the characteristics of the utilities to understand what our backup and recovery options are. It's often beneficial to have multiple types of backup to cover the different possible types of failure. Your main backup options are the following: a logical backup using pgdump, and a physical backup, which is a file system backup. The pgdump, I need to move a little bit. The pgdump utility comes in two main flavors, pgdump and pgdumpall. The pgdump utility has the -f or -F option, to produce backups in various file formats. The file format is very important when it comes to restoring your backup, so you need to pay close attention to it. As far as physical backup is concerned, in this chapter we will focus on file system backup using pgstart backup and pgstop backup. However, it is important to note that PostgreSQL has its own built-in application for physical-based backups, PG-based backup, which relies on the streaming replication protocol. As authors, in order to distribute the content more evenly, we have decided to cover PG-based backup and streaming replication in the next chapter, Chapter 12, Replication and Upgrades. That's fun. I love replication. Very difficult. Well, everything's relative, but it's not easy to set up. Well, it's fun, but it takes a minute if you're not used to it. How to do it. The following table shows the features that are available. Depending on the backup technique selected, the details of those techniques are covered in the remaining recipes in this chapter. And we have a table here. I'm not gonna, not a table, but it is a table, but not a physical table. A table with information, like a database table with rows and columns. So there's a whole bunch of stuff here. Yeah, I'm not reading all that. Let's skip ahead a little bit. Okay, there's more. Of course, there's more. Choosing physical backups is a safer approach. If you can take a logical backup, then you can also take a physical backup and then extract the same logical backup from it, while the opposite is not possible. For more details, refer to the extract a logical backup from a physical one recipe later in this chapter. Hot logical backups of one database. Logical backups make a copy of the data in the database by dumping the content of each table, as well as the object definitions for the same database, such as schemas, tables, indexes, views, privileges, triggers, and constraints. How to do it. The command to this is simple. The following is an example of doing this when using a database called pgbench. pgdump -F c pgbench, and then >dump file. Alternatively, you can use the following command: pgdump -F c -f dump file pgbench. Okay. Finally, note that you can also run pgdump via the pgadmin4 GUI as shown in the following screenshot. I did not know that. I'm not really all that fond of using GUIs, and I'm not sure why. But I don't really use pgadmin at all. I'm a PSQL guy. I just like to do everything using PSQL. I feel like it gives me a better understanding of what's actually going on, rather than just like ClickOps. Because that's what, I guess that is basically. Because you can't really, I guess maybe you can, I don't know, because I don't use pgadmin, but I feel like with PSQL it's a lot easier to automate in, like, Kubernetes with like a job or something, or just even like a shell script that runs a simple PSQL command every like day or whatever, and then syncs it up to S3 or something. That would be my go-to. produces a single output file. This output file can use the split command to separate the file into multiple pieces if required. The pgdump archive file, also known as the custom format, is lightly compressed by default. Compression can be removed or made more aggressive. Note, even though by default pgdump writes a SQL script, an SQL script, directly to standard output, it is recommended to use the archive file instead by enabling the custom output format through the -fc option. As we will cover later in this chapter, backing up in the form of archive files will give you more flexibility and versatility when restoring. Archive files must be used with a tool called pg_restore. The pgdump utility runs by executing SQL statements against the database to unload data. When PostgreSQL runs a SQL statement, we take a snapshot of transactions that are currently running, which freezes our viewpoint of the database. The pgdump utility can take a parallel dump of a single database using the snapshot export feature. We can't yet share that snapshot across sessions connected to more than one database, so we cannot run an exactly consistent pgdump in parallel across multiple databases. The time of the snapshot is the only moment we can recover to. We can't recover to a time either before or after. Note that the snapshot time is the start of the backup, not the end. The snapshot time is the start of the backup, not the end. Okay. When pgdump runs, it holds the very lowest kind of lock on the tables being dumped. Those are designed to prevent DDL from running against the tables when the dump takes place. If a dump is run at the point at which other DDLs are running, then the dump will sit and wait. If you want to limit the waiting time, you can do so by setting the --lock-wait-timeout option. Since pgdump runs SQL queries to extract data, it will have some performance impact. This must be taken into account when executing on a live server. The pgdump utility allows you to take a selective backup of the tables. The -t option also allows you to specify views and sequences. There is no way to dump other object types individually using pgdump. You can use some supplied functions to extract individual snippets of information in the catalog. The pgdump utility works against earlier releases of PostgreSQL, so it can be used to migrate data between releases. Note, when migrating your database from an earlier version, it is generally recommended to use pgdump for the same version of the target PostgreSQL. For example, if you are migrating a PostgreSQL 10.7 database to a PostgreSQL 11, you should use pgdump version 11 to remotely connect to the 10.7 server and back up the database. Drink some more. As far as extensions are concerned, pgdump is aware of any objects, namely tables and functions that have been installed as part of an additional package, such as PostGIS or Sloaney. Thanks to that, they can be recreated by issuing appropriate create extension commands instead of dumping and restoring them together with the other database objects. Extension support removes such difficulties when restoring from a logical backup. Maintaining the list of additional tables that have been created as part of the software installation process. Refer to Managing Installed Extensions recipe in Chapter 3, Server Configuration, for more details. There is more, because of course there is. What time was pgdump taken? The snapshot for pgdump is taken at the beginning of a backup. The file modification time will tell you when the dump is finished. The dump is consistent at the time of the snapshot, so you may need to know that time. If you are making a script dump, you can do a verbose dump. Continuing this previous example, you just need to add the -v This adds the time to the top of the script. Custom dumps store the start time as well. And that can be accessed using the following command. This is a very long command that just essentially grabs the head of your dump file. I love the word dump file. It's so stupid. See also, note that pgdump does not dump roles such as users and groups and table spaces. Those two are only dumped by pgdumpall. See the following recipes for more detailed descriptions. There's a new recipe, and I think this will be the last recipe that I do for today. Actually, probably not the second to last one because it's a really short one. Hot logical backups of all databases. If you have more than one database in your PostgreSQL server, you may want to take a logical backup of all the databases at the same time. How to do it? Our recommendation is that you repeat exactly what you do for one database to each database in your cluster. You can run individual dumps in parallel if you want to speed things up. Once this is complete, dump the global information using the following command: pgdumpall-g. To back up databases, you may be told that you need to use the pgdumpall utility. The following are 4 good reasons why you shouldn't do that. If you use pgdumpall, the only output produced will be a script file. Script files can't benefit from all features of the archive files, such as parallel and selective restore of pgrestore. By making your backup files this way, you will immediately deprive yourself of flexibility and versatility at restore time. The pgdumpall utility produces dumps of each database, one after another. This means that pgdumpall is slower than running multiple pgdump tasks in parallel, one against each database. The dumps of individual databases are not consistent to a single point in time. As we pointed out in the hot logical backups of one database recipe, if you start the dump at 4 and it ends at 7, then you cannot be sure exactly what time the dump relates to. It could be any time between 4 and 7. That's with pgdumpall. Okay. Options for pgdumpall and pgdump are similar in many ways. Pgdump has more options and therefore gives you more flexibility. See also, if you are taking a logical backup of your databases for disaster recovery purposes, you should look at the hot physical backup options instead. Backups of database object definitions. Sometimes it's useful to get a dump of the object definitions that make up a database. This is useful for comparing what's in the database against the definitions in a data or object modeling tool. It is also useful to make sure that you can recreate objects in the correct schema, tablespace, and database with the correct ownership and permissions. How to do it? There are several important commands to note here. The basic command to dump definitions for every database in your PostgreSQL instance is as follows: pgdumpall -- schema - only greater than myscriptdump.sql. This includes all objects, including roles, table spaces, definitions, databases, tables, indexes, triggers, constraints, views, functions, ownerships, and privileges. If you want to dump PostgreSQL role definitions, use the following command: pg_dumpall -- roles only -- roles - only greater than myroles.sql. If you want to dump PostgreSQL tablespace definitions, use the following command: pgdumpall -- tablespaces only greater than my tablespaces.sql. If you want to dump both roles and tablespaces, use the following command: pgdumpall -- globals - only greater than my globals.sql. The output is a human readable script file that can be re-executed to recreate each of the databases. That's cool. Note, the short form for the globals only option is -g, which we have already seen in the previous recipe, logical backups of all databases. Similar abbreviations exist for -- schema - only, which is -s, -- tablespaces - only, which is -t, and -- roles only, which is -r. There's more. In PostgreSQL, the word schema is also used to organize a set of related objects of a database in a logical container. Similar to a directory, it is also known as a namespace. Be careful that you don't confuse what is happening here. The -- schema only option makes a backup of the database schema, that is, the definition of all objects in the database and in all namespaces. To make a backup of the data and definitions in just one namespace and one database, use the pgdump with the -n option. To make a backup of only the definitions in just one namespace, use the in just one namespace and one database, use the pgdump with both -n and -- schema only together. You can also take advantage of a previously generated archive file. See hot logical backups of one database recipe and generate a script file using pg_store as follows: pg_store -- schema only my dump file greater than myscriptdump.sql. And I think we'll leave it here for now. The next one is a standalone hot physical backup, which sounds like a fun time. We're at page 460 now. I think we read about 11 pages, which is pretty good. But kind of sad considering this page has 578. This book has 578 pages. So yeah, I hope you enjoyed this video, and I will see you next time in another video, hopefully.